Hello everyone, welcome to Edu Plus Leisure YouTube channel. Meeting you all back again with another video. So let's continue with 2024 A-level chemistry MCQ paper discussion from the 11th question. So FeCl3 react with ammonia and water to produce FeOH3 thrice and NH4Cl. So they have given the mass of each reactant and some masses of the product formed. Now we have to find the maximum quantity of FeOH3 that we can obtain from this reaction. So I have written the balanced reaction. FeCl3 plus 3 ammonia plus 3 water is giving FeOH3 and 3 NH4Cl. That is the balanced reaction. So here just we have to write the balanced reaction, then only we can compare with the stoichiometry. Now they have given 97.5 gram of FeCl3, 97.5. Alright. Then ammonia they have given 34 gram and 27 gram of water. Now we have to find maximum amount of FeOH3 form, right? So before that we have to find the moles reacting. So first we'll convert all of these to moles. So you can see I have converted all the masses into moles. Okay, so 97.5 gram of FeCl3 was present, that divided by its molar mass is 0.6 mole. 34 gram of ammonia is 2 moles. 27 gram of water is 1.5 mole. Now we have to compare this. You have 0.6 gram of FeCl3, 2 moles of ammonia, 0.6 mole of FeCl3 and 1 moles of water. Now first we have to find the limiting reagent. So you can see FeCl3 is to ammonia is to water ratio is 1:3:3. Okay, so if you take 0.6 as the limiting reagent, we have to now check with each one. If you take 0.6 as that, then you need 1.8 of ammonia and 1.8 of water, but you can see water is not sufficient, then this is not the limiting reagent. Now I'll take 2 as the limiting reagent value. So if 2 is the limiting reagent, here it should be 2/3. Then water you should have 2 moles because ammonia to water ratio is 1 mole, no? So but you can see only 1.5 moles of water is there. Now if we take water as the limiting reagent, then you need 1.5. If you have 1.5 mole of water, you need 1.5 mole of ammonia and 0.5 mole of FeCl3. You can see that's all coming like ammonia and FeCl3 are in excess also, therefore water only act as the limiting reagent. So with respect to water, if you see how much of FeOH3 you will get, 3:1 is the ratio, therefore moles of FeOH3 is 0.5 moles. Now we know the moles of FeOH3. Now we have to find the mass of FeO3, that is moles into molar mass. Molar mass of FeOH3 you can take by adding 56, then 16 times 3, 48 and 3. Then you will get 8 and 6, 14, 17, 1 balance, 5 and 4, 9, 10, 107. So 107 into 0.5 is, that's the half of it, 53.5 gram. Third one is the answer. So this is a very simple calculation. Actually we can do it very quickly. This is stoichiometric calculations. So answer is number 3. Now 12th one, let's see. Bond energies of HHCl, HCl are given below. So enthalpy change of the reaction they are asking. So here they have given the bond enthalpies. Now we have to use the equation to find the enthalpy change. Delta H broken bonds minus formed bonds. Broken bonds minus formed bonds. So broken bonds you can see half of HH bond is broken. Then HH it is 436. Another Cl bond also half they have broken, half into 242. Now this addition you have to subtract with the HCl bond formation, which is 431. Then we will get the answer. So if you simplify this, you are getting the answer minus 92. Therefore the answer is minus 92 kilojoule per mole. I hope that's clear. Now let's go to the 13th question. Which of the following figure correctly represents the titration curve when 0.1 mole per decimeter cube HCl is added to 25 cubic centimeter of 0.05 mole per decimeter cube carbonate aqueous solution? Now here they have given the volume, right? 25 cubic centimeter of carbonate solution, obviously, so that should be in the beaker. And from the titration flask you are adding HCl. That's what you can see in the x-axis of the graph. You have HCl. So initial pH should be definitely a basic pH. No, yeah, carbonate aqueous solution will have a basic pH initially. Therefore we can reject 4 and 5. Now in this type of titration there are two equivalent points. So that is, first equivalent points is when carbonate is converting to HCO3 minus, Next equivalence points is when bicarbonate is converting to H2CO3. So due to both of these, there will be two equivalent points seen in this reaction. So let's consider for the first equivalent point value. So I'll take the moles of carbonate. Okay, so that is concentration in volume is 0.05 into 25 into 10 to the power minus 3. So that will be 125 means 1.25 into 10 to the power minus 3 moles. So carbonate to HCl, anyway H plus, they will react 1:1 ratio. Okay, therefore HCl also you need 1.25 into 10 to the power minus 3 moles. So we'll find the amount of HCl you need for the first equivalent point, volume. Okay, volume is equals to moles over concentration. So moles you can see that is 1.25 into 10 to the power minus 3. Okay, concentration is 0.1. So it will be so this down 10 to the power minus 1, no? So this will become 10 to the power minus 2. So 1.25 into 10 to the power minus 2, that means 12.5 into 10 to the power minus 3. 12.5 into 10 to the power minus 3 decimeter cube, that means 12.5 centimeter cube. So I found the volume of HCl required for the first equivalence point, that is 12.5 centimeter cube. How did I find it? I found the moles of carbonate. So 1:1 only it will react. So that same moles only you need for HCl also. Keeping that moles and concentration, I found the volume of HCl required for the first equivalence point. That is 12.5 cubic centimeter. Now obviously first one is not the answer. There should be two equivalent points. So either should be 2 or 3. So you can find it from the volume. Here you can see the third option, 12.5 only. The first equivalence points has been depicted. Therefore answer is the third one. So that is how you have to take the answer for that. I hope it's clear. Now let's see the 14th one. Consider the following reaction. Now here you can see benzaldehyde, no? So it is reacting with Br2. So aldehyde, if you take, it's a meta directing group, so Br should obviously come in the meta position. They are asking the which of the following is the resonance structure of the intermediate which gives the major product of the reaction. So it should be a meta one, no? Obviously it should be a meta product. Then it can't be in ortho para positions. This is not. So either it should be 1, 2, 1, 4 or 5. So you obviously know first one is actually the correct resonance structure. So we are drawing the resonance structures, right? So now I'll show it. Now here it cannot be a plus. Here no plus should come here, not here. Here this one you cannot have a bond here, because Br and H is there, that the carbon here has already 4 bonds. So you can't put a double bond again, it will become 5 bonds. Therefore obviously answer is the first one. So if you have practiced writing the resonance structures, it's a easy guess actually. First one is the answer. Now consider reaction of KMnO5 with H2O2 in the presence of dilute H2SO4. Now you need the coefficients, no? Okay, just we'll balance it quickly. Okay, first I'll write the reaction weight. Now here we can see MnO4 minus will reduce, then hydrogen peroxide should oxidize. So it is oxidizing for O2, reducing for water, oxidizing for O2. So this is +7 becoming +2. Here oxygen's oxidation number is -1. Since there is 2 oxygen, it is -2. Here it is 0. So here +2 oxidation. Here you can see -5 reduction. So -5 is multiplied by 2, +2 is multiplied by 5. So 5 and 5. So this is multiplied by 2 and 2. Now we have to see the charge balancing. This side you have -2 charge. This side you have +4 charge. Now this is an acidic medium. Now in acidic medium we are adding H pluses to the more negative side. So here I will be adding 6 H pluses. Then 6 plus and -2 is getting +4. So both the side have the same charge. So 6 H plus will be added. Then we can see oxygen has to be balanced. This side 2 4s are 8, 5 2s are 10, 18 oxygens are there. This side we have only 10 oxygen. Therefore I am putting another 8 water molecules. You can see hydrogen is also automatically balanced. Yes, 16 16. So acid is 6, MnO4 minus is 2, H2O2 is 5. 2 5 6, answer is number 3. If you know balancing, this is actually a very easy question. Okay, now let's see the 16th question. A first order gas phase reaction, A becoming B plus A occurs in a closed container at a given temperature. The half-life of the reaction is 20 seconds when the initial pressure is 100 kilopascal. Half-life is 20 seconds is same. The half-life of the reaction when the initial pressure is 200 kilopascal at the same temperature. Now first we'll write the equation for half-life for a first order reaction, that is 0.693 over Okay. So you can see half-life of first order reaction is independent of the initial consideration. It is depending only on the rate constant. We know that rate constant depend only on the temperature. When temperature changes, rate constant will change. Then the half-life will change. But here the pressure is increasing but at the same temperature. Therefore half-life remains the same because rate constant also remains the same. Therefore answer is 20 seconds. Very simple question. If you know the theory well, you can directly answer it. Consider the reaction shown below. The enthalpy change of vaporization of water. Vaporization of water means what? Gas, liquid to gas, no? Yeah, water liquid to gas. Water liquid to gas, you need the enthalpy. Okay. Then what you have to do? We have to take water liquid this side and cancel all of this, no? So if I name this equation number 1, now here thermochemical equation method only I am going to use here. Okay. So what I am going to do is I am going to subtract 1 minus 2. Okay, now see H2 plus half O2 minus H2 minus half O2 is giving H2O gas minus H2O liquid. So you can see H2 cancel, half O2 cancel, minus H2O liquid you can bring to other side as plus H2O liquid. Then H2O liquid is becoming 2. So 1 minus 2 will give you the enthalpy change. That means minus 241.8 minus 285.8. Then you have to add 285.8. No, you will get a positive value. So let's see the value. Answer is plus 44. That means 44 kilojoule per mole. Answer is number 4. So now let's go to the 18th question. When solution of a reactants A and B are mixed in a beaker, a spontaneous reaction takes place with lowering of the temperature of the mixture. Spontaneous reaction means delta G is negative and taking place with lowering of the temperature of the mixture. Lowering of the temperature means temperature is reducing, means endothermic reaction, no? It's endothermic reaction. Then delta H should be positive. Now that is okay. Now how can you find delta S? Now for that we'll write the delta G expression, will do delta H minus T delta S. So delta H is positive. Okay. Now we'll say if suppose delta S is negative, if it is the fourth answer, if delta S is negative, then minus T into minus delta S, okay, minus T into minus delta S giving you a positive T delta S, right? It's giving you a positive T delta S. If you solve this, you will obviously get a positive answer, where delta G is becoming positive. If delta G is positive, it cannot be spontaneous. Okay, it cannot be spontaneous. Therefore, obviously delta S should be positive. Then this T delta S term will be negative, and if that value is greater, delta G will get a negative value. Okay, and it is possible. Therefore, answer is number 5. That is how you have to find the sign of the entropy. Now let's go to the last two of this video, 19th and the 20th one. 19th question, select the correct statement with regard to the given reaction. Now here we have to find whether it is behaving as a Lewis acid or a Lewis base. That means whether it is behaving as a acid or base. Usually we should know that acid means it can release H plus ions to the solution. A base can accept an H plus ion to the solution. Now here you can see what has CH3NH2 done. It has gained an H plus, right, from the water molecule and release an OH minus. Now CH3NH2 has gained an H plus. That means it's a Lewis base actually. Okay, CH3NH2 has gained an H plus. No, that's a Lewis base. So that thing is correct. In the forward reaction, CH3NH2 is behaving as a Lewis base, not a Lewis acid. So first option we can neglect. Then now water we don't take, it is behaving as a Lewis base or Lewis acid. Then let's see the third option, CH3NH2 behave as a Lewis base in the forward reaction, while OH minus is behaving as a Lewis acid in the reverse reaction. In the reverse reaction, OH minus is gaining an H plus and becoming water, right? In the reverse reaction, OH minus gains an H plus and becomes water. So that is also behaving as a Lewis base. So CH3NH2 is accepting an H plus and becoming CH3NH3 plus and becoming that in the forward reaction. So it's a Lewis base. In the reverse reaction, we can see OH minus is gaining an H plus and becoming water. So there also OH minus is gaining H plus. Therefore, it is also acting as a Lewis base in the reverse reaction. Therefore, perfect answer is the fifth one. Let's quickly finish the 20th question. Consider the enthalpy diagram shown below. the enthalpy change of hydration of Ca2 plus gas is minus 1650 kilojoule per mole. The hydration enthalpy of Cl minus gas we have to find. Now let's I feel like making a making a thermochemical cycle would be easier for this. Now you can see I am taking Ca2 plus gas is reacting with 2Cl minus and forming CaCl2. For that it is minus 2258 kilojoule per mole. Now they have given the hydration enthalpy change of Ca2 plus. So Ca2 plus gas becoming Ca2 plus aqueous is minus 1650. But same thing we don't know for what? Cl minus, no? We don't know for Cl minus. Now let's say the hydration enthalpy of Cl minus is X, but here I will take it as 2x, okay, because you have 2 Cl minus, no? Yeah, and then we can form the reaction. CaCl2 solid also they have given the hydration. That is this way, minus 120 kilojoule per mole. Now we can apply the Hess's law. So this way, minus 2258 plus minus 120 is equal to minus 1650 plus 2x. Now let's see what's the solved answer. 2258 120 you have to add now, minus 2378 you will get. Then I am taking minus 1650 this side, then it is plus 1650, that's equal to 2x. Now let's find the value. So minus 2378 plus 1650 is giving you minus 728. Now that you have to divide by 2 because they are asking for Cl minus, no, per mole only you have to find, but this is for 2 Cl minus. So if you divide it by 2, you will get the X value as minus 364 kilojoule per mole. So successfully we have discussed the next 10 question also. Thank you for watching.